So in this video, we will derive the equation for the frequency observed by an observer if a source S is traveling towards an observer, right? As the source S also emits a wave. Alright, so what would the apparent frequency be observed by this observer? Now, in order to derive this equation, so let's start off with this source S. Now, it is producing waves at a frequency of Fs, and therefore, the time interval between the waves that it creates is Ts. So you can imagine the time between two crests to be the time Ts. So at the same time, it is also moving forward with a speed of Vs. Now, do not confuse the speed Vs, which is the speed of the source, with the speed of the wave. Because as the wave is produced, it also travels forward with a speed of Vw. Alright, so now let's say the wave, the source S emits a wave here, okay, and after a time of Ts, the wave travels to this position. So the distance which is traveled by the wave, let's call it S1, will be equals to the speed times the time, which is the speed, which is Vw, times the time Ts. That means we are finding the distance traveled by the wave crest after a time Ts, that means after the period Ts. So at the same time, do you still remember that this source is traveling forward with a speed of Vs? So therefore, in the same time Ts, what is the distance traveled by this source? Let's call this S2. So this is your S2. So what is the distance traveled by your wave source? According to the same formula, distance traveled by the source is equal to the speed of the source, Vs, times the same time Ts. So this means that the source is now at this point. So it will start to emit a wave crest from here. Alright, so what will happen is now the distance between the first wave crest and the second wave crest is now a distance of S1 minus S2, which is this remaining distance. So that is the distance between the two subsequent wave crests. So the distance between the two subsequent wave crests, which is S1 minus S2, will be VWTS minus VSTS. So therefore, what would the for an observer, what would be the period between two observed wave crests be? So the period, which is the time taken between two wave crests, is given by the formula. The observed period, so TO, is given by the formula distance divided by the speed. So what is the distance between the two wave crests? We have said is VW TS minus VS TS. So divide by the speed of the wave, which is VW. So you can factorize the TS and you will get VW minus VS over VW, then the whole thing times TS. Now, so this will be the observed period. So what will be the observed frequency? The observed frequency will be the inverse of the observed period. So you just have to inverse the whole thing. So 1 over TS, VW minus VS. So what you will notice now is 1 over TS will give you the frequency of the source. So times VW over VW minus VS. So therefore, what you will notice is your observed frequency will be higher than your source frequency, because your VW divided by VW minus VS, which is smaller than VW, will give you a number of more than 1. So therefore, your observed frequency will be higher than your source frequency.